After a little bit of incubation, when Intellectual Ventures and we started thinking of a first spin-off, it sort of came to light that, hey, why don't we think about satellite communications as being an area where we can bring a product into being. And it turns out that the metamaterial architecture, I'll call it, allows you to create an antenna that has the same functionality as a dish or an electronically scanned antenna, but with a much lower cost. Hygge was formed to commercialize the opportunity for satellite communication. Their market is really to be the antenna, the dynamically reconfigurable antenna that can communicate with satellites, either geosynchronous or other types of satellites like low Earth orbit satellites or others that are on the move, so they can be tracking them continuously. The metamaterial antenna is now being developed by Hygge. Really just have almost no power requirements. They can run off of a USB port rather than burning a kilowatt. That's a big difference, and was really the first company that demonstrated that there is a huge potential for metamaterial antennas. You can also think about when you're in a plane turns a bit and your TV signal's gone or your Wi-Fi is lost. That problem is going to be solved. That's actually another company that was spun off called Pivotal Communications or Pivotal Comware, again using a metamaterial design and solution. The Echodyne, which is another one of the spin-off companies that we've made for metamaterials, is really a dynamically reconfigurable metasurface antenna. It's like the Hygge antenna, except it's tailored for collision avoidance. Currently, there's all sorts of sensors on your car now telling you when to merge, when not to merge, when to turn left, when to turn right, making sure you don't back over someone. All those sorts of things. This is a dynamically reconfigurable metasurface antenna. So this is really, if you could look closely enough, you'd see little metamaterial elements all along this guide. You send in wave energy from one side or the other, and each one of these points radiates it out. So this whole thing is the aperture of an antenna, and on the back you see some drive electronics. So the Echodyne system doesn't look exactly like this, but it's pretty close. The whole thing is driven by a computer, in our case a little Arduino microprocessor. This is all manufactured on a circuit board. So this is very standard technology. That's why it's so inexpensive. A lot of the applications of the future, including self-driving cars, require an enormous number of sensors to be on vehicles for collision avoidance, for communication. And this is a great opportunity for all of the spin-off companies to play in.